Hello students and welcome to the quick solution of All India Cast Test Series JEE Advanced 2020 Test 4A Paper 1 Core DNA Physics. Let's move to question number 1. In question number 1, a closed organ pipe of length 30 cm and an open organ pipe of different length contains gas of densities ρ0 and 4 ρ0 respectively. The compressibility of gases are equal in both the pipes. Air column in both the pipes are vibrating in their first overtone with same frequency. The length of open organ pipe is. We know that F into lambda is equal to speed of sound, that is V, or it can be given by bulk modulus B divided by rho. So in the first case, in case of closed organ pipe, when it is vibrating in its first overtone, then we can write F into the value of lambda is 4L1 by 3, that is equal to bulk modulus, that is B, divided by rho naught. And in the case of the open organ pipe, we can write frequency same F into lambda 2 is L2 is equal to B divided by rho naught is 4 rho naught. So if I take the ratio, that is L2 divided by 4L1 by 3, then it comes out to be 1 by 2. So from here, the value of L2 comes out to be 1 by 2 of 4 by 3 of L1, and the L1 is 30 centimeter. So if I solve this, it comes out to be 20 centimeter. So option C is the correct answer. Let's move to question number 2. In question number 2, a body with zero initial velocity slips from the top of an inclined plane, forming an angle of 37 degrees with the horizontal. The coefficient of friction mu between the body and the plane increases with distance x from the top according to law mu is equal to 3 by 4x. Maximum velocity acquired by the body during its motion is. So let's analyze the situation. Suppose this is an inclined plane and this makes an angle theta with the horizontal, and this is the body. So if I write the equation of dynamics, then m into v dv by dx, that is m into a, can be written as mg sin theta is acting in this direction and mu mg cos theta is acting in the opposite direction. So that is equal to m into g sin theta minus mu. The value of mu is 3 by 4x into g into cos theta. So from here, it is equal to v dv is equal to g sin theta minus 3 by 4 g cos theta into x into dx. So at x equal to 0, the velocity v is equal to 0, and at any x, the value of v is v. So from integration, we get the value of v square by 2 is equal to g sin theta into x minus 3 by 4 g cos theta into x square by. Now we have to find out at what value of x the maximum velocity occurs. So from this equation we can see that the maximum velocity occurs when the value of acceleration is 0. So from this equation we will find the value of x comes out to be 1. So if I substitute the value of x is equal to 1, then this comes out to be the value of theta is 37 degree. So on solving, v square by 2 comes out to be 3g by 5 into 1 minus 1 by 2. So that is half. So on further solving, the value of v comes out to be root 6 meter per second. So option D is the correct answer. Let's move to question number 3. In question number 3, a string passing over smoothly carries a block at one end while its other end is attached to a vibrating tuning fork, and the string vibrates forming 8 loops. When the block is immersed in water, 10 loops are formed. The relative density of the block is. So we know that the frequency in the case of when the string attached at both the ends is given by n by 12 into under root of t by mu, where n is the number of loops formed. So in the first case, number of loops are 8. So we can write 8 by 12 under root of T1 by mu. Let the tension is T1 in this case in this string. So this must be equal to 10 divided by 12 into under root of T2 by mu. So from here we get 4 by 5 square is equal to T2 by T1, and in the case when the block is immersed in water, the value of T2 can be written as, if the value of T1 is mg, and the value of T2 is mg into 1 minus 1 upon rho r, where rho r is the relative density. So if I solve this, the value of rho r comes out to be 25 by 9. So option C is the correct answer. Let's move to question number 4. In question number 4, a small size object of density rho plunges into a liquid of density 2 rho after falling freely from a height h above the liquid surface. The motion of the object will be, assume no loss of energy and no splashing of liquid, and the depth of liquid is greater than h. So let's analyze the situation. So this is a small ball and its density is rho, and it is at a level of h from the liquid surface, and the density of liquid is given as 2 rho. So the time taken by the ball to reach from here to the vicinity of the liquid surface is let T1. Then if this height is h, then the value of T1 is under root of 2h by g, as the motion is free fall motion. After this, when the ball immerses in the liquid, it will experience buoyancy in the upward direction. So B is here and mg is here. So if I find out what is the acceleration, then acceleration in the medium can be written as B. So that is weight of liquid displaced. So V into 2 rho into G, that is B, minus mg. So m can be written as V into rho into G divided by m. So that is V into rho. So we can see that the value of acceleration is g, upward. So due to this upward acceleration, the object will get retarded, and after some time its velocity becomes 0. So the time taken in this interval is let T2. So T2 is again can be find out as 2h by g, as the acceleration in the first case and the retardation in the second case are same, so the time will also same. So we can say that it will perform a periodic motion with time period 2 times T1 plus T2. So if I substitute the value of T1 and T2, so it comes out to be 4 times under root of 2h by g. So option D is the correct answer. Let's move to question number 5. In question number 5, a uniform rod AB of length L is maintained at temperature 0 degrees Celsius at end A and 100 degrees Celsius at end B. Thermal conductivity of rod varies linearly from K to 2K from end A to B. Temperature at midpoint of the rod is. So this is a rod and its length is L, which is given in the question. This end A is at temperature 0 degrees Celsius and this end B is at temperature 100 degrees Celsius. This is the midpoint, and we have to find out the temperature of the midpoint of this rod. So if I go at a distance x from here, then the thermal conductivity K dash can be written as K plus 2K minus K by L into x. So it comes out to be K into 1 plus x by L. Now let the rate of heat flow in the rod is Q dot, which is same in every cross section. Then I can write Q dot, that is dq by dt, is equal to K. So I am writing through this cross section. So K into 1 plus x by L into A, let the area of cross section is A. So A into dt by dx. So dt by dx. Now if I rearrange this differential equation, then it can be written as Q dot divided by Ka into dx divided by 1 plus x by L is equal to dt. So first of all, I have to integrate this equation from x equal to 0. At x equal to 0, the temperature is 0, and at x equal to L by 2, the temperature would be T. And in the second case, if I integrate from x equal to L by 2, at that instant the temperature would be T, and at x equal to L, the temperature would be 100. So if I integrate these two equations and solve for the value of T, then the value of T comes out to be 100 divided by ln 2 into ln 3 by 2. So option C is the correct answer. Let's move to question number 6.